All right, so I was making my video starting with problem number 36 and something went wrong and my video got erased. So here is all of my work for 36, 37, and 38. I'll just go quickly through. The key with all of these problems is to draw a good picture. So if we have our space shuttle 1 kilometer above sea level, here's my space shuttle. I just drew a little circle. And then it's climbing at an angle of 3 degrees for 80 ground kilometers. So when they say it's on the ground, that's the flat part of the triangle. So we're always trying to draw a right triangle. And we want to know how far above sea level is the space shuttle after its climb. So when I draw my right triangle, I make my height over here, and I can, with my 3 degrees, I have an opposite and an adjacent. So I would use a tangent ratio. Tangent of 3 is x over 80, which x is the opposite. And then to get x by itself, I multiplied by 80 on both sides, and I got x equals 4.19. And here's one of those tricky ACT things. 4.19 is actually a choice, but if you remember back at the beginning, they said it was already 1 kilometer above sea level. So if we're looking at how far it is off the ground, we have this 1 right here plus whatever our x is that we found. So we had to add 1 to that, so we get B is the correct answer. Number 37, I found a little bit challenging because of the description of the situation. Making a retaining wall to shore up the side of a hill, and the angle can be 75 degrees or less with the ground. So I drew my hill in here, and then I put my 75-degree angle with the ground, and there's the ground. And our question asks us how far from the base of the hill is the base of a 15-foot slanted wall. So the first time I drew it, I put my 15 over here where my straight up and down distance is, because normally I'm used to walls being at a 90-degree angle. But this is a retaining wall, and it's along a hill, and it's a slanted wall. So since they give us that information, I'm able to move my 15 over to the slanted part, or the hypotenuse, and I see that I have an adjacent that I want to know and a hypotenuse. So that's going to be my cosine. Cosine is adjacent over hypotenuse. So I set up a cosine ratio, and that equals the adjacent over the hypotenuse, multiply out by the 15, and I get 3.88. So in my calculator, you can see that's right here. I did 15 times the cosine of 75, and that's where the 3.88 comes from. And in number 38, we have a drawbridge. One end is at the ground, and when we lift up a drawbridge, it starts out at 5 degrees. It's a 60-yard long drawbridge, but we see in problem number 38, the raised end is actually 50 above the ground. And all my answers are in degrees, so I am looking for, this is not going to be 5 anymore. This is going to be some new angle after we've raised the drawbridge a little bit. So I see here that I have opposite and hypotenuse. Sine is opposite over hypotenuse. So I set up my ratio. Sine of some angle is 15 over 60. And the way that we find missing angles in trigonometry, when we know both pieces here, we use what's called the inverse sine. And so I get that by using my second button, and right above the sine is the inverse sine. And so I can plug in my numbers, and it'll give me the angle that has that as a sine. So here I've left off on number 39, and I've drawn my picture, but I haven't done the math yet. So here's my hang glider, and I'm 80 meters above the ground, and I've got these two horses, horse A and horse B, and the angles of depression. So normally an angle of depression would be up here, looking down, but those angles are not inside the triangle, so I transfer them down here to the base. So I'm going to find out how long is this line segment and how long is this side of a triangle by using trig ratios. So I'm looking for, I know my opposite and I don't know my adjacent. So I'm going to say tangent of 10.4 is 80 over, I'll call that B, for that's where horse B is. And so I'm going to move my B over, and I'm going to divide both sides by tangent. So I get B equals 80 divided by tangent of 10.4. And so that number is going to be 80 divided by tangent of 10.4. So that's going to be 435.9. And then to get A, I'm going to do the same thing. I'm going to say A is tangent of 80 divided by, no, A is 80 divided by the tangent of 8. And that is 569.23. So I'm going to subtract those two numbers, because they asked me how far apart the horses are, and I get 133.3. So that's choice A. All right, number 40, Zach, Rachel, and Maddie are unraveling a huge ball of yarn to see how long it is. As they move away from each other, they form a triangle. The distance from Zach to Rachel, okay, so I'm going to go Zach, Rachel, Maddie. Zach to Rachel is 3 meters. Rachel to Maddie is 2.5 meters. So again, I didn't draw it to scale. The distance from Maddie to Zach is 4 meters. Find the measures of the 3 angles in the triangle. So here we have, this is not a right triangle. So we have to use other laws of trigonometry to be able to figure out what some of the angles are. So we definitely do not have an equilateral triangle. And so I am going to pause this while I figure out whether or not to use the law of sines or the law of cosines for this one. Okay, so to figure this out, I look at what information do I know. I know all 3 sides of the triangle. So when I know side, 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 I'm going to use the law of cosines. And that law goes like this. The angle opposite of a side, that's called angle R. So I'm going to set this up. 4 squared equals 3 squared plus 2.5 squared minus 2 times 3 times 2.5 times the cosine of R. So I really only have one missing thing in this problem. And this equation, so the formula, I'll give it to you generally, looks like this. C squared equals A squared plus B squared minus 2AB cosine of C. So that's the law of cosines, and it all has to do with which side is opposite of the angle. So I am going to take 4 squared and I'm going to subtract 3 squared plus 2.5 squared. So that equals 0.75 equals negative 2 times 3 times 2.5 times the cosine of R. So now I'm going to multiply negative 2 times 3 times 2.5 I get negative 15. So I'm going to divide by negative 15. 0.75 divided by negative 15 is negative 0.05 is the cosine of r. And remember, when we want to find an angle, we have to use the inverse cosine. So I'm going to go inverse cosine of that answer. And that tells me that angle r is 92.87 or 92.9. Okay, so already that is the only one that has that for angle r. So I know that I am done, and choice A is my best choice. So you will go over law of cosines and law of sines when you do Algebra 2 next year again. But the trick with law of cosines is that you want to always find the largest angle, which is across from the largest side first. Okay, so now let's see what we have. We have a parallelogram, and we have some questions about the parallelogram. So first things first, we know parallelograms have two pairs of parallel sides. So opposite sides are parallel. We know that consecutive angles are going to add up to 180. And we know that opposite angles are congruent. So CDA is going to be congruent with CBA or ABC because opposite angles are congruent. And that's just a law of parallelograms. Okay, so for number 42, I don't need to use the picture. I am just going to figure out if my opposite sides are congruent. So I have to use the distance and slope formulas to figure out if the opposite sides are congruent and if they have the same slope. So I'm going to draw a very rough sketch of this just so I can picture which sides are opposite. So I'm going to go to 3, negative 9 for A, 10, 1 for B, 10, 1, 4, 10 for C, and negative 9, 3 for D. So that way I know, A, B, and C, D are supposed to be across from each other. So let me check. How long is AB? So if I'm finding distance, remember I'm going to use the distance formula, and that's going to be x2 minus x1 squared plus y2 minus y1 squared. So to find AB, I'm going to go x2 minus x1, 10 minus 3 is 7, and 1 minus negative 9 is 10. So 49 plus 100, square root of 149. And then I'm going to find CD. So I'm going to go negative 9 minus 4 is negative 13. And 3 minus 10 is 7. Negative 7. So negative 9 minus 4 giving me 13. I can already tell I don't have the same number there. Let me add 13 squared, 169 plus 49, just to get the right answer. So that's square root of 218. So the opposite sides are not congruent, so I can stop right there. And then let me just check my answer to make sure I didn't make some kind of a mistake. A. Okay, I'm good. So next, number 43. This is a rhombus. YZ equals 12. Find AB. So if you know the definition of a rhombus, the rules are all four sides are the same. So I could say that's 12 and be done. I don't need to know anything else. So next one, I just have some points here, And we need to know, is it a rhombus, a rectangle, or a square? So again, I'm going to do a quick sketch just to visualize where my points are and which ones are across from each other. So I'm going to go 5, 10 for A, 4, 10 for B, 4, 9 for C, and 5, 9 for D. Okay, so I don't really have to use distance formulas here. I can see A and D at 5, 10, and 5, 9, that's 1 unit. And from A to B, from 5 to 4, that's 1 unit. And from B to C, from 10 to 9, that's 1 unit. And 1 unit. Alright, so all these are right angles, all these are the same length. So this is a square. The only issue with these quadrilaterals is that they have these definitions that if you fit the definition, then it can be more than one. So if something is a square, the issue is what do squares have? Squares have all 4 sides the same, opposite sides are parallel, opposite sides are the same length. So you got to look at what's the definition of a rectangle. Rectangle has opposite sides parallel, opposite sides are congruent, and the rhombus has the same thing. So if something is a square, it's also a rectangle and a rhombus. So that is why A is the best choice, even though we would traditionally call that a square. This is probably not a question like they would ask you on the ACT as far as the definitions of your shapes, but to be able to draw it out like this and recognize the side lengths would be a fair question. Okay, so we're at 17 minutes, so we can keep going a little bit. If A and B are midpoints of the legs, find ML. So I do know that this, I can mark these things as being the same. What we have here are some similar lengths, some similar segments. So I can tell you if we have a 32 and a 36, then the next one is going to be bigger. It's going to be in the same ratio. So let me just do a little comparison here. So from 36 to 32, if I reduce this fraction, 4 goes into both, that's 9/8. So if I take that number times 36, I get 40.5. So I am going to go ahead and choose choice D. That is just a rule of similarity. We just haven't applied it yet to trapezoids or any quadrilaterals. So looks like we're getting into some circles problems now, so I'm going to save that for my next video, starting with 46. So thanks for watching. Just wanted to give you all a little dose of cuteness. There's my friend Zeus, who is helping me by hanging out with me while I make videos for you guys this morning. Hey Zeus. Hey big guy. Zeus. Can you look at the camera? Nope. All right, see you later.